Today we're going to be talking about the area between two curves. So how I want you to look at this is we're going to have the larger y, and we're going to take away the smaller y, and that's going to get us the in-between area between two curves. So how you want to look at this is we're doing the integral from a to b of, and I'm going to write it out here, big Y. So the y that is larger, so in this case that is f of x minus the little y which in this case is g of x with respect to x. So you take the larger function, I often think about it also as larger function, so the larger function minus the smaller function. Okay, our first example. So in this case we have the square root of x and we have y equals x cubed. And I'm going from 0 to 1 because these two curves intersect at 0 and at 1. Now I can tell that from my picture, but that's not always the case. You might have to do some algebra to find the intersection point. So from 0 to 1 of the big Y, which is root x, minus the smaller y, which is x cubed, with respect to x. So then I take my integral and we get 2/3 x to the 3/2 minus 1/4 x to the 4th, evaluated from 0 to 1. And I have 2/3 minus 1/4. And I still want you to plug in the 0. I want you to get in the habit of plugging in the 0, because sometimes if you don't get in that habit, sometimes these values are going to get you something other than 0 and you're going to screw up. Okay, so when we simplify that, we get 5/12. Now integrating with respect to y. So it's the same concept. Just now you're going to have big X minus small x. And even though some of this goes in the negative area, it's fine. Now what you have to keep in mind, when you're integrating and you're going to the y-axis, everything needs to be in terms of y. So the values that you're integrating from c to d, have to be in terms of y. Now we have the big Y, the far function from your axes. I like to think about it, I like the big X. I think that's a better way of thinking about it. Big X minus the quote small x, which is g of y. Now, even if this negative area, what your integral is going to take care of that, because it's going to subtract a negative area, which is still going to be positive. And in this case, these functions are all in terms of y, and we're integrating with respect to y. So if you're going to the y-axis, all of this is in terms of y. So in this example, we have to integrate in relation to y, not only because the equations are all in terms of y, but the graphs, I don't know, it's kind of hard to explain. I have trouble explaining it. The graphs, one graph is not exactly on top of the other. One graph is always to the right of the other. Like if you were to draw a line here for the little rectangle of how we built area, that graph, that function, you'd have to integrate of this function minus that function. And that would be really hard for us to do because we're not going to be able to solve that for y. So we have to integrate with respect to y, which means our equations need to be in terms of y, which means what we have to think here is we have to think of big X minus little x. Now, which one's the bigger? Think about it. Big X minus small x. The smaller one is going to be the negative one. So set up your integral. And we're integrating with respect to y. So everything's in terms of y. What are the y's that bound us? 0 and 1. And we have big X minus small x. So our big X is 12y squared minus 12y cubed. And then we have 6y squared minus 6y. So now simplifying that, combining your like terms. What I'm going to do first, because I don't want to make a silly algebra mistake. A lot of calculus teachers, we always joke that it's the calculus. The calculus is not what kills you. It's the algebra that kills you. Distribute your negative. Now combine your like terms. So I have a 6y squared minus a 12y cubed plus a 6y dy. I should probably have parentheses around that. That's better notation. Okay, so now we integrate. When we integrate that, we get 2y cubed minus 3y to the fourth plus 3y squared, evaluated from 0 to 1. Okay, so now we plug in 1. So we have 2 minus 3 plus 3. Now still plug in your 0. Yes, you guys are going to realize that this is 0 minus 0 plus 0. But if you get in the habit of not plugging in 0, sometimes I'm going to trick you and it's going to be an e to the x function. You're going to screw it up. Okay, so just remember to always plug in the 0. Just make your life easier so you don't screw something up. That simplifies to be 2. Our next example, in this case we have to pick. Now what I want you guys to keep in mind is I want you to draw little lines through. And as long as one function is always, quote, on top of the other, then you can integrate with respect to x. But as I'm drawing my lines here, there, y equals x is above this crazy function, but here we switch, and I have another function that's on top. So it's inefficient to do this with respect to x. If I erase this, and I draw now horizontal lines, I have one function always to the right of the other function. So it's more efficient for us to integrate with respect to y in this case, which means that I need to solve this equation up here for x. I multiply both sides by 48, and then I square root. Again, I did that because I need my equations all in terms of y. So your y boundary is from 0 to 12, 0 to 12 of the big Y, big X technically, is this function here, just that function there, minus this function here. That function's technically solved for y, and we're integrating with respect to y. Okay, something you want to keep in mind here. You can simplify that radical, but I might make a mistake, especially if I don't have a calculator. But I can separate that out. And what I actually might even do, I lied, let's write that to the 1/2 power, because that's the variable that I'm actually going to be integrating. So, find your integral, and then we have, this is 2/3, because my y goes to the 3/2 power, minus 1/2 y squared, from 0 to 12. Now, this gets into a bunch of algebra, okay? 48, square root of 48, can be broken down into 4 root 3. So that becomes 4 root 3 times by 2/3 times by 12 to the 3/2 power. So 12 to the 3/2 power becomes basically the square root of 12 3 times. So 12 root 12. There's still a perfect root I can pull out. So I can pull out a 4, which is really a 2. So this becomes 24 root 3. So that's 24 root 3 minus 12, 1/2 of 12 squared, minus, again, another 0 minus a 0, just making sure that I get 0 there. Simplifying all that out, I get 120. In this example, we have one function that is strictly not above the other function. Here at 0, the blue function switches to be the little y. So you have to break up your integral in this case. So I'm going to have one integral from -4 to 0 of something with respect to x, and I'm going to add to it the integral from 0 to 4. Now again, remember, big Y. Our big Y from -4 to 0 is the blue function. And then I'm going to subtract from that the little y, which in this case is -x squared plus 2x. And notice how I put that in parentheses so I don't forget to distribute my negative. Now, in the other case, from 0 to 4, the purple function is our big Y, so we have -x squared plus 2x minus something else, what happens to be the blue function in this case, which is x cubed minus x squared plus 14x. What I recommend you do, put this expression in y1, put this expression in y2, so that in your calculator syntax, all you're doing is doing the integral of y1 minus y2, and add to that the integral of y2 minus y1, and that's going to make your life a lot easier. I did that in my calculator, and I got 128. Okay, please for me, make sure your lesson summary is submitted on time.